All right, so let's go ahead and get started about graphing cosine. So the last video we talked about how to graph sine. We looked at the periodicity of sine. We looked at how it'll continue to kind of go back and forth between one and negative one, at least for the parent function. But even as we go through various transformations and so on and so forth, um, it still continues that same general pattern. It might go a little bit higher, it might be able to go a little bit lower. It might, you know, take a longer time to just finish one way. It might take a shorter time. That all those different transformations, but the general behavior is consistent. And we're going to continue off that with cosine. So with cosine, you see, we know that unit circle, the radius is 1, and very similar, um, like our sine function, our cosine will turn into x over 1, which of course is just x. In a similar way, sine was just y. Here, cosine, we have just x. So instead of looking at the uh, y values that we did for sine, we're actually going to look at just the uh, x values, and I'm going to label this as 1 and -1. So let's go ahead and take a look at how that looks. So as we start at 0 degrees or 0 radians, my x value is 1. So even off the bat, we're already extremely different because before for sine we started at 0, but here we're starting at 1. At pi over 2 or 90 degrees, we go to 0. So at pi over 2, I'm going to just go ahead and draw in my 0 value. Then as we rotate, we go to pi or 180 degrees. My x value is -1. That's down here. Another 90 degrees or a pi over 2. I'm at 3 pi over 2 or 270 degrees. My x value is now 0. And as we rotate one more time back to 360 or 2 pi, my x value is once again 1. So you can see that my value is my graph does look similar yet different, because although I have the general shape, it doesn't seem to be starting the same place, right? So it's kind of like the same kind of graph, but it seems to be at a different spot. Now, if I go backwards, right, just like we talked about last time, from if I'm starting at 0 and I go clockwise, this is a negative rotation. So this is a negative pi over 2. I'll be at 0. And if you continue that pattern, we'll find ourselves like so. Now, I think what's nice about the cosine graph is that it's a little bit harder to mess up because you can't go anywhere else, right? This has to decrease in terms of like if you're going to the left. You know, that graph is not very good. I don't really like it. I'm going to redraw that. That's also not very good. Now, like I said before, for sine, there really shouldn't be any like sharp teeth type graphs. It should all be nice and curvy. Now, mine's not perfect, but it looks something like that. Now, we talked about it last time where we had a sine function that's going to look something like this. You can see that at 0, it's 0, and it's going to trace out the y values for my unit circle. And this is exactly what we graphed out last time up to 2 pi, but it's going to continue to repeat itself. But if we add in cosine, you see now it starts at 1, and at 2 pi, which we eventually hit, we will go back to 1, and it's got a different starting point. So if I put these two together, you'll see that one traces out the x values of my unit circle while the other one traces out the y. And you know what? They are essentially the same graph, just it's kind of been like moved, right? One of them has been kind of moved over. And we shouldn't be surprised that they are virtually the same graph because it's the same circle, right? And for both x and y, they'll go through all the positive and negative ones, and so on and so forth. So again, this shouldn't be a surprise, but obviously they have their differences as well. Very similar to before, everything is pretty much the same as my sine function. My midline is still going to be the line that's essentially, I mean, I think the name aptly describes it, right? It's the middle line, it's the middle of the function. the line in the middle of the function, while my amplitude is going to be how far away I am from the top and the bottom from my midline. Now, you'll see that in this case, my maximum is at a different location than before, right? As we mentioned, but my value is still 1 here, while my minimum is still also 1. So amplitude is still 1. I should probably label my midline. My midline is y is equal to 0. And finally, my period. Well, if you take a look at my period here, again, period is how long is one wave essentially, or how long is one complete wave or one complete cycle. So you can see here, it's probably easy to see from a max to a max, right? This is 0 to 2 pi. This length is 2 pi. So my period is 2 pi. And again, frequency is how many cycles or how many waves, how many repetitions of a wave do I have in a 2 pi length. And of course, here in this case, I just have 1 as well, right? So frequency and period are very closely related. In fact, one is the reciprocal of the other. So they are very closely related. We're going to talk more about that. The key features, you'll find that it's essentially the same as sine. In fact, they're all the same other than just a couple. My domain, again, it's negative infinity to positive infinity. This should make sense. It'll go on forever and ever, repeating itself to the left and to the right. The range is still negative infinity. I'm sorry, -1 to +1, right? We continue to oscillate between these two values. My y-intercept is different because now I'm going to my maximum initially instead of the midline. These are the only two that's different. It is now an even function because I have symmetry with respect to the y-axis. We mentioned the amplitude, the period, as well as the midline already, so I'm not going to go over that. But you see the domain, range, y-intercept, and odd evenness they're all fairly similar. In fact, my end behavior is also the same. It doesn't exist. Again, we're oscillating between -1 and 1. It's never going to some specific value, right? Because at any point, I shouldn't say any point, but predictably, we know it's going to, it's not like forever going towards a number. It goes to 1 as often as goes to 0, as often it goes to -1. There's no like end to where I'm going to be, right? Where am I, right? So there's no end behavior. Again, these 5, it's just to show you the periodicity of the graph, meaning how it continually repeats itself over and over and over again. So these kind of describe my all possible, right? X-intercepts, maximum, minimums, increasing, decreasing intervals. But again, it just meant to show you that it's going to repeat forever and ever. Now, if I do limit the graph, though, if I say, I only want to look at this graph from -2 pi to 2 pi, then there's going to be a limit, right? If I cut off my graph here and here, then of course there's only going to be 1, 2, 3 maximums, 2 minimums, 1, 2, 3, 4 x-intercepts. I'm going to have 1, 2 increasing intervals and 2 decreasing and 2 increasing intervals. So if I limit my domain, then there's only certain places where I have these key behaviors or key features. But if I'm not limiting it, then there's an infinite number that exists. So anyway, my graph is going to be very, very similar. I'm going to look at my ABCs as well, my A cosine BX plus C. They all stand for the exact same thing. Now, again, I don't remember in the last video if I included this other relationship that we actually use more right now. I don't know why I didn't include it. But the period is 2 pi over the b value. For now, we are going to be using this one more, at least for this week, because this is going to be more about when we have a graph, how do we write our equation? This is more from an equation going to a graph, but we'll take a look at it. So just like before, I'm going to label all the values that I have. I have 3, 1, 0 for my A, B, and C because I have A cosine of bx plus c. My amplitude is just my A value, so that's going to be 3. My period, I can calculate that in just 1 second, while my midline is y is equal to 0. Just y equals to whatever the c value is. Again, it is a line, so make sure you have y equals. Now, we said period is equal to 2 pi over b, meaning 2 pi has to be over 1 because that's our b value. So therefore, my period is 2 pi. Okay, my midline y equals 0. I'm going to go ahead and draw that in just to help myself. I would encourage you, even if you're using pencil or hopefully not pen, but if you're using either, that you are drawing these in just to kind of help guide yourself as well, right? Because you never know. Because I actually had a student kind of mess up. It's all right. But her drawing got messed up because she forgot to draw one of the lines. And so her graph was a lot smaller than she anticipated or she had meant it for it to be. So, but that's okay. So let us draw in my amplitude, which is 3, meaning 3 above my midline, but also 3 below my midline. Now, for cosine, I am going to start at a max. So at 0, I start at my maximum. Because it's 2 pi for my period, if I start at 0, I must end at 2 pi. Okay? Right in between, so 2 pi divided by 2, which is pi, I have my minimum. Then in between my max and min, I have to go through my midline somehow, right? I'm not going to magically appear on the other side. So I must cross the midline, and it's going to be right in between. So my graph looks something like this. And I'm going to, again, do the similar thing here, right? If I'm going to the left, that means I have to go down first. And this is my graph from negative 2 pi to 2 pi. Okay, now it's not supposed to be curvy like that. It's hard to draw in the XP pen. Okay. So I'm going to do as many examples as I can. I'll also go over some examples I did in class because there were some pretty good questions. I think they're good examples. So I might change some of these just so you get a variety of examples. I did period with b equals to 1 already in the last problem. So this is 2 pi. Midline is y is equal to negative 2. Again, once you have these values calculated out and stuff like that, I think it will be much easier for you to sketch. So there's my midline. My amplitude is 1, so 1 above and 1 below my midline. Not a great railing there, but that's all right. That's all right. Once again, at 0, I'm going to start at my max. Period of 2 pi means if I start at 0, I'm going to end on my max at 2 pi. In the middle, which is pi, is my minimum. Again, I must cross through my midline right in between those. And at this time, I'm going to kind of just go through the whole thing here. And I'll just draw one continuous curve. Hopefully, I don't mess it up too bad. I think I messed up here. I did right here. I was like, those points are a little close. Okay, so I got boom. Okay, something like that. It looks better than last time, I think, but I think it's a small space, a little bit hard. I'm too used to drawing on the Promethean board. All right, now this is where we get a little bit tricky. 3, 2, 1. My amplitude is 3. My midline is y is equal to 1. Now my period, 2 pi over b becomes 2 pi over 2. Now my 2's will cancel. So my period is actually pi. And we're going to see how that affects the graph in just a second. So again, let's just go ahead and do what I know. My midline is y equals to 1. My amplitude is 3. So 1, 2, 3 above. And 1, 2, 3 below. Start at my max at 0. But my period is pi, meaning I'm have to end at pi. Now, halfway between my maximum and minimum, my two maximums is my minimum. So that means pi divided by 2, which is pi over 2, is my minimum. While in between these guys, which has been nicely drawn out for us, is where my midpoints are. And same thing here again. If my period is pi, pi plus pi is 2 pi. So I end at 2 pi. And again, the right in between them is my minimum. And I got to draw my intermediate ones too. So same deal here. I'm going to go ahead and draw these guys in here. And I'm going to sketch it out here. Ugh. So it will be a little bit sharper. I'm still trying to do my best so that it's not like sharp teeth necessarily, but just, I'm going to redraw that. That's just, I can't. I know, very exciting. Just watching someone draw a graph. All right, let's jump back into what I was talking about frequency for a second, though, right? Here I see the B value is 2. And again, remember that frequency means, how many waves there are in a 2 pi length. Again, from 0 to 2 pi is here to here. All right, this is 2 pi, a length of 2 pi. Right, this distance is 2 pi. Right, so how many completed waves do I have here? Well, I have one wave here because it's a maximum to a maximum. That's 1. And I have one wave here. Right, that's another wave. So that's why my B value is 2. There's 2 waves in a 0 to 2 pi. Okay, so I'm going to erase that just so my graph doesn't get too crazy, but hopefully that does make sense. All right, let's go on to the next problem. I got cosine x plus 2. That means that my A is 1, B is 1, C is 2, amplitude of 1, period of 2 pi. My midline is y is equal to 2. So my midline is y equals to 2. My amplitude is 1 above and 1 below. And my period is 2 pi. So meaning, if I start at my maximum, I'm going to end at 2 pi. In between them is my minimum. And I must go through my midline somehow. Like, oops, too low. Right, because I drew this in for myself, I can see that, oh, wait, I went a little too low to try to graph, right? So just make sure, nice and curvy. Okay, now I think I'm going to change it up. Let's not do 2 cosine of 2x, but instead, I think something like the homework is 2 cosine of 1/2 x. Okay, so let's do that instead. So that's still 2. My b is now 1/2. My c is 0. Amplitude of 2. We'll talk about period in just a second, but y is equal to 0. P is equal to 2 pi over b. But my b is now 1/2. Now, maybe you know how to do this off your head. I know some people have trouble with this. This is the same thing as 2 pi divided by 1/2, right? I can rewrite this as 2 pi multiplied by 2, or 2 over 1. So this is equal to 4 pi. 4 pi. So that's a little different than what we're used to. And that's okay. That's all right. Let's just go ahead and try to draw this and see what happens. Right? Again, my midline is at 0. So y equals 0 is my midline. I'm going to go ahead and put that in there as a guide for me. I have my amplitude of 2, so up 2, down 2. Now, My graph starts at in my max still, but with a period of 4 pi, that means I end at 4 pi, which is way off in the distance. Okay, but that's okay because if I end at 4 pi, which is like all the way, down here somewhere, whatever, um, the middle of that between 0 and 4 pi is 2 pi. So 2 pi is where my minimum is. Okay, so even though I know that's way all the way down there and it's off of our area, that's okay. I still have my ending point, not ending point, quote unquote, but we stop drawing at 2 pi normally, so this is where we're going to stop. But between 0 and 2 pi is my midline point, which is right here. And I'm going to have the exact same thing to the left. So it looks something like this as a period of 4 pi. And notice something else here, right? My b value is 1/2. And indeed, this right here is half of a wave. It is not a complete wave, it's only half. So that's consistent. I'll do one last one. Again, I'm going to change it up again. I'm not going to do this one. This is boring. Let's do 2 cosine of 4x. Let's go crazy here. Plus 3. Woo, we are insane. Insane in the membrane. Amplitude is 2. Midline is y equals to 3. My period, again, p is equal to 2 pi over b. My b value is 4. So that means my period is pi over 2. So with that, let's go ahead and draw in all the little guiders for me, my bumpers and my whatnot. Plus 3. Amplitude of 2. Now, start at my max as always. But now my period ends up pi over 2. So that's here. And in between that is my minimum. And in between my max and mins are my midpoints, midline points. So this is a very, very short wave. It is a very, very short wave. So I'm going to do my best to draw this here. But it's going to be very, very, very sharp. But you'll notice that they're still not like teeth. Right? I'm still drawing it with curves to the best of my abilities, which I know you can too. Okay, almost there. Got a lot of points. All right. Okay, I missed it. All right, there we go. Again, you see the 4, mean how many waves there are in 0 to 2 pi. Again, max to max, this is 1. Max to max, this is 2. Max to max, this is 3. Max to max, this is 4. All right, so I hope this makes sense. I think that it's very similar to the sine function. Now, with sine, if you have 4x, sine of 4x or sine of 1/2x, it's the same exact thing, nothing crazy. So I do hope that this does make sense. If not, feel free to leave a comment or ask me in class. Either way is perfectly fine. Thank you for watching.